So the wave-particle duality. What is the meaning of wave-particle duality? It means that the particle can behave like a wave and wave can behave like a particle. That's called wave-particle duality. But how physicists reach this point that particle can behave like a wave or wave can behave like a particle, it's all started with light. So in the beginning, the light was considered to have a particle nature. And the renowned physicist Newton gave an idea that light is actually having a particle nature. It can travel from one place to another in the form of particles, and that is known as Newton Carpuscular theory. So scientists, they were having a debate about the nature of the light, like whether light is a wave nature or a particle nature, and it all started with the concept that light is having a particle nature. So Newton supports that light is having a particle nature, whereas some of the scientists, they believe that light is having a wave nature. So the first one, giving an idea, Newton suggests that because, like example, if light is having a particle nature, if we block the sunlight, so it will form a shadow, and light can also reflect. So Newton explained that that is known as a Newton's corpuscular theory, and he explained that light is having a particle nature. So light strike the surface and it bounce back. That he explained reflection, and he explained the formation of a shadow, how the shadows are formed when these particles of the light are blocked, they're not able to pass through, so there will be absence of the light under that, and it's result in a formation of shadow. So Newton theory, it was accepted for long time, but then there was a wrong assumption in his theory. What was the wrong assumption? He suggested that the light is traveling faster in solid. In his theory, he suggests light is moving much faster in solid. But practically, light travel much faster in vacuum or gas as compared to liquid, and liquid it is faster compared to solid. So solid, the speed of a light is much slower. Why he think like this, that light is traveling faster in solid? Because he was influenced by the sound, the nature of the sound. About the sound, we know sound is mechanical. Sound need particle to travel, and the speed of sound is much faster in solid. So he was able to explain reflection, he was able to explain the formation of the shadows, but he was not able to, like his wrong assumption, the theory was that he suggested that light is traveling much faster in solid. The speed of a light is fast in solid. That's why, but this was practically wrong, so his theory was discarded. Then the first scientist, the physicist basically, explained the idea that light is having a wave nature was Huygens. Huygens suggests that light is having a wave nature. And he explained, because using a wave nature, he explained reflection, he explained refraction. But the problem arises in case of Huygens. He assumed that whole universe is made up of hypothetical medium which is called ether. He's, this is what he assumed. He assumed that whole universe, whole space, whole world is made up of hypothetical medium, and he suggested that this hypothetical medium is ether. But he was not able to prove the existence of the ether, because this is just a hypothetical. In reality, it is not there. And reason why he assumed this, because in his mind he was having an idea that because sound needs a medium to travel, so he think light also required a medium to travel. So the Huygens explained reflection and refraction using a wave nature, but what was a wrong assumption in his theory, that he suggested that light is having a Like light is a mechanical, it required a medium to travel, and whole universe is made up of hypothetical medium ether. But he was not able to prove the existence of the ether, or later different experiments were carried out but not able to show the presence of ether. That's why his theory was also discarded. Then the Thomas Young performed an experiment which is known as the Young's double slit experiment. The Young's double slit experiment actually explained two phenomena. When the light passes through a gap, it diffracts, and when the light waves in the form of wave, it is acting, it interfere. So light diffract and light interfere. So Thomas Young performed this experiment and he proved that light is having a wave nature because it can diffract, it can interfere. When the light passes through a gap, it is spread out, we call diffraction. When two light waves combine at one point, so there will be interference. So that makes the physicists, all the physicists believe that light is having a wave nature, and light, because it diffract and it interfere. So to explain this wave nature, like what kind of wave is this? So Max Planck explained the idea that electromagnetic light is having a electromagnetic nature. Electromagnetic means it can travel through vacuum. Light is not a mechanical, it does not require a medium, so light is electromagnetic. And he give the formula that if we want to find the energy of the light, how we can find, we can use the formula E is equals to HF, or E is equals to HC over lambda. So these are the formulas which can be used to work out the energy of the electromagnetic radiation. E is equals to HF, or E is equals to HC over lambda. But in early 20th century, there is an effect which is called a photoelectric effect. And photoelectric effect cannot be explained by a wave nature, as we already discussed. Like why wave nature cannot explain this photoelectric effect. The particle nature can only explain this photoelectric effect. So what is the photoelectric effect? It suggests when light in the form of particle, in the form of photons, falls on the metal, the electron in the metal surface, if the energy of the photon is more than or equal to the work function, these electrons at the surface absorb energy and they will go out. And this phenomena is called a photoelectric effect, and it can be only explained by particle nature. Wave nature cannot explain this photoelectric effect. So, and this was explained by Einstein, and he got awarded a Nobel Prize on this. And he suggested that energy of the photon can also be calculated by using a same formula that we use to calculate the energy of electromagnetic radiation, which is E is equals to HF, or E is equals to HC over lambda. But this photoelectric effect can only, like, it can explain the particle nature can only explain this photoelectric effect. The wave nature cannot explain this photoelectric effect. So de Broglie, the German physicist, he came up with an idea. He suggests light is having a dual nature. What is the meaning of dual nature? It means it is having two natures. Light can be a wave, light can be a particle. But it is not like same time light is wave and particle. No, it depends on which phenomena we are observing for light. Example, reflection. We can explain reflection. We can explain the reflection by wave. We can explain the reflection by particle. We can explain refraction. Refraction means change in speed when moving from one medium to another. By wave, we can explain refraction by particle. But we can explain diffraction and interference is only by wave. Also, the Doppler effect, the change in frequency, can only be explained by wave nature. Whereas reflection, refraction, and the photoelectric effect, the spectrum, line spectrums, that we'll discuss later. The Compton effect, you will not study in this your course. The Compton effect. So these are some phenomena which can explain the particle nature. So some of the phenomena, the light, like some of the phenomena, the light is acting like a wave. Some phenomena, light is acting like a particle. So he sums up this idea. He suggests that light is having a dual nature, and the formula which relate the momentum, because momentum is for particle and wavelength is for wave. So lambda is equals to h over mv, where mv is the momentum. So we can also write lambda is equals to h over p, where lambda is for wave and momentum is for particle. So light is having a dual nature. Light can act like a wave, light can act like a particle, depending on which of the phenomena we are considering. So we cannot say light is a wave nature. We cannot say light is having a particle nature. It is having a dual nature. Like its nature depend on the phenomena which happen. Which is, so this is refers to wave particle duality. Is it clear the concept how the scientists believe initially light is particle, then later they know that is wave, and then again they know that particle, and that de Broglie sum up the idea that it is having a dual nature. Any question or a doubt till this point? And that is known as a wave particle duality. Particle can behave like a wave or wave can behave like a particle. Then spectra or spectrum. So what happened? What is a spectra? What is the concept of spectrum? As we have atom consists of, in the central of the central part of an atom consists of a nucleus which is having neutron and proton, and around the nucleus there are electrons. And for every atom there are 7 shells occupied depending on the number of electrons, but for every atom there are 7 shells. So when I draw, even I draw for hydrogen, hydrogen consists of 1 proton in the nucleus, there is no neutron, and around the nucleus electrons are revolving. So that is K shell 1, second shell, third shell, fourth. The distance between the successive shell decreases. Like in the beginning, there's a greater distance between them, the 2 shells, but as we move to higher shell, the shell spacing, the distance between the shells start to decrease. So first, second, third, that is fourth, fifth. This is example the sixth, and the it's like overlapping also happen in the orbitals. Though this is a seventh shell. So these are the 7 shell. And hydrogen, what it consists of? It consists of 1 electron in the first shell, which is revolving around the nucleus. Now what happened when this hydrogen is there in its original shell? We call this shell for the first electron, we call that is a ground state. The ground state also refers to the natural state of this hydrogen in a ground state, what happened? It does not absorb any, and it is there moving at a normal energy. But once it absorbs the energy, and this the transition can only be explained by particle nature. So what happens, like example, if there's a photon and each shell is having its own energy. If I say the first shell example 10 joules, the second shell is 30 joule, then 50 joules or 45 joules, then 50 joules, and so on. Now what happened? There's a photon. The photon is there which is having energy of 20 joules. So when this photon, which is having an energy of 20 joule, this electron absorbs this photon. So now, because to jump from one shell to another, how much energy? In the first shell, electron should have 10 joules. So it is having 10 joule. To reach the second shell, electron should have 30 joules. So what will happen if we provide energy equal to the difference in the energy of the two shells? As a result, what will happen? This electron will jump from lower shell to higher shell. So if the energy of the photon is 20 joules, which is equivalent to the difference in energy of the two shells, the electron jumps from lower shell to the higher shell, and this electron will be there now in the higher shell. But because electron does not belongs to this shell, so it will revolve, it will move in this shell for some time, and after some time this electron jumps back to its original shell from where it belongs to. As a result, when it jump or it return back to the original shell from which it belongs to, it will emit out that photon which was absorbed, and that photon will be equal to difference in the energy of the two shells. So this photon will go out as a result when electron return back to its same original level. So this emission and absorption of the photon is known as a spectra or spectrum, which is refers to light, because photon is an energy particle, light particle, or a quantized particle which of light or packet of light. So we call that as spectra. When the electron is absorbing the energy, we call that as absorption line spectra. And when it is emitting out the photon, we call that as emission line spectra. So this happen together, like when electron absorb energy equal to difference in the energy of the two shells, it will jump to the higher, and then it return back. When it return back, it release that photon equal to difference in the energy, and we call that the term line means it refers to a fixed amount of energy. So if the energy of the photon is less than the difference in the energy of the two shells, like example, for electron to jump it need 20 joules, but if there is a photon which is not having 20 joule, this photon is example 15 joule, so will the electron jump? Will it travel to the higher shell? What will happen to the electron? Will it jump to a higher shell if the energy of the photon is less than the difference in the energy of the two shells? So if the energy of the photon is less than the difference in the energy of two shells, so there will be no transition, because electron minimum need this much amount of energy to jump from one shell to another. And if there were two photons, will the electron jump? If there are two photons, each photon is having energy of 15. Will this electron jump to the second shell? No, it won't jump. Why? Because one electron can only absorb one photon at the time. So once it absorbs a photon of 15 joule, it will use that energy. If that energy is not sufficient, electron will not jump. Once it utilizes that energy, it will then absorb another photon. So one electron can absorb one photon at the time as well. So as a result, even we have two photons or three photons which are having energy less than the difference in the energy of the two shells, there will be no transition. Electron will not be able to jump. And what will happen if we have a photon which is having energy which is more than the difference of the two? In that case also it won't jump. Like example, the difference in the energy is how much? This is a 10 joule, like in this shell it is 10 joule, and here in this shell it is 30. So if I say I provided 25 joules, so when I provide 25 joule, so 25 joule means it should be somewhat reach this point, not the third shell, not the second shell, not the third shell. It should be in between. But even when we provide the energy equal to the not equal to the difference of the energy of two shells, either more or less, so this electron will not jump. Electron only jump when the energy which is supplied is equal to the difference of the energy of the two. And that is an evidence, this is actually an evidence that there are shells. Because if there were no shells, any kind of energy when we supply the electron should go out, like it should move out, but it does not happen. This is an evidence, the light spectrum is an evidence that there are shells existing within an atom, and specific amount of energy cause the electron to transit. If we supply energy less than or more than, the electron will not jump. So as you can see here, say hydrogen, this is a hydrogen atom and all the seven shells are there. Occupied is different, but in case of hydrogen, it has only electron in the first shell. And these are the energies given, like minus 13.6. Most of the energy it is given in electron volt, and 1 electron volt is equals to 1.6 into 10 to the power minus 19 of the joules. That is the equivalent. So you have first shell, second shell, third shell, and so on. In case of hydrogen, because electron belongs to the first shell, so first shell is a ground state for this electron. Now, when we supply the energy, example, this is 13.6 minus 13.6, negative energy. What is the meaning? It is called like a potential well. Example, if you are on the ground, you have zero potential energy. So when you are on the ground, you have zero potential. When you climb a mountain, your potential energy will increase. You will have positive potential energy. But example, if you fell in a or if you fall in a well, so what kind of energy you will have? You will have negative potential energy. So same concept is used here. Like atom, like electrons are like in the well. That's why the lower energy, it's shown as a negative energy. Like the lower shell is shown as negative, and when electron is outside the atom, it is like a ground level for it, which is 0 electron volt. So when electron is below this level, we call that as like a potential well or energy well, we can also say. That's why it is negative energy shown. Negative energy is just giving an idea that it is inside the well. So at an atom, when it is at the surface of an atom, it has zero energy. But when it is inside the atom, so it will have a negative energy, and these values are given. So minus 13.6 for hydrogen, minus 3.4, minus 1.51, minus 0.85, minus 0.544. So what is the difference in the energy here? Like 13.6 minus 3.4. So when I take the difference of these two energies, this will give us 10.2. So means electron to jump from this ground state, if there is an electron, it need 10.2 electron volts to jump. So when a photon energy is equal to 10.2, this electron will jump. It will stay there in the higher level, and after some time it will return back to its own ground state, and it release that photon which was absorbed. So when it was absorbing a photon, a specific amount of energy, we call that as absorption line spectrum. When it gives out the specific amount of energy, we call that as emission line spectrum. And to calculate the energy released by the photon or energy absorbed, we calculate the difference of the two shells. So E2 minus E1 is equals to HF, because E is equals to HF is the formula, or E is equals to Hc over lambda is a formula which we use to calculate the energy of the photon. So when electron jumps from one level, lower level to higher level, it absorbs energy, and after some time it return and release that photon back. But what if, like here, the difference is 10.2? Electron volt is the difference. So if the photon energy is 10.2, it will absorb and it will jump. But example, if the photon energy is 10.5, will the electron jump? The energy difference is more than, like the photon energy is more than the difference in the level. Will the electron jump or transit from lower shell to higher shell? Like from first shell to the second in case of hydrogen? So when the energy of the photon is more than the difference in the energy, the electron will not absorb. So this will not cause any transition. But when we check the first shell and the third shell, what is the difference in the energy between the first shell and third shell? So that is 30 minus 1.51 and minus 13.6. So difference in the energy is 12.9 between the first and the third shell. So if the photon energy is 12.9 electron volt, so what will happen? This electron will absorb this photon and it will not jump from first shell to second. Now it will jump from first shell to third shell, because the photon energy is equal to difference in the energy of the first and the third. Same way, if the photon energy is equal to, like this is 0.85 and 13.6. So if the photon energy is 12.75 electron volt, which is a difference in the shell 4 and 1, difference in the energy. So electron will not jump from first shell to second or first to third. It will directly jump from first to fourth. So it depends on the energy of the incident photon. If it is equal to the difference in the first and second shell, it will jump to second shell. If it is equal to difference in first and third shell, for case of hydrogen, it will jump to third shell. And if the energy is too much, like because this electron here, it is 13.6. So if we provide the energy equal to 13.6 electron volt, a photon, electron absorb this photon, and this electron will not jump in any shell. Now it will go outside because it has enough energy, 13.6, so it will go outside the atom, and that is called ionization. Ionization means like removal of electron from an atom. So when we provide energy equivalent to the difference from the ground state to the infinity to the last shell, or more than that, the electron absorb and it will go outside the atom, and we call this as ionization energy. So this is an evidence that every element having a shells. Otherwise, if there were no shells, for example, for hydrogen, if there were no shells, then what should happen? There should be no quantized energy which hydrogen absorb, high electron absorb. If I supply 2 electron volt, if I supply 2 electron volt, this electron absorb photon and it should move up and start to rotate. If I supply 1.2 electron volt, electron should move. If I supply 3 electron volt, electron should move. All the energies, electrons should move and transit from one position to another, but this does not happen Why this does not happen? Because every atom is having the shells, and these shells are at fixed positions. So that's why we say these are quantized energy levels. Quantized energy level means energy levels are at a specific position, and these energy levels are different for different elements. That's why energy levels are like fingerprint of the elements. So when you check for hydrogen, say the difference, like the first shell is 13.6 and the second shell is 3.4. But when we take for helium, it won't be same. Example, first is 13.6, so next might be maybe 3 or -3 will be there. When we take another element like lithium, so when we are taking lithium, the first shell is 13.6, but second shell might be 3.1 electron volt. So all the elements have different position, different gaps between their shells, and that is why this this is refers to a fingerprint of element. So using the line spectrum, we can identify what is the element present in the material, or what kind of element, or what is the composition. That is how the stars, the galaxies which are far away from us, we are able to predict their composition. We are able to say that sun is made up of mainly hydrogen and helium. We are So what is the reason how we are able to predict this? Because the photons which are coming from different stars, or example sun or sun-like star, so these photons, their energy matches with what? Their energy matches with the transition of hydrogen. So when hydrogen element electron transit, they give out a photon, and that energy of a photon balances with hydrogen or matches with hydrogen and helium. That's how we are able to say that this star consists of hydrogen and helium. So these spectrums, which are known as the line spectrum, are known as also known as the fingerprint of the element. It's like identity of the element. Every element is having a unique line spectrum. So this was a model which is given by Bohr, a Danish physicist, that electrons from an atom revolve around the nucleus in a shell, and electron only travel in some special orbits, like there are fixed region. You don't find like this electron will move like this. No, this is wrong. Electron move in a specific definite region or quantized region, and they have a specific energy. We call them as energy level. And the electron can gain or lose energy by jumping from one allowed orbit to another and emitting out the photon. And we can calculate the energy of the photon by taking a difference of the energy of the two levels. So if I subtract E2 minus E1, I will get what energy of a photon is being released by this atom. Is it clear, the concept of atomic levels and the line spectra? That why different elements have different atomic levels or difference in the level, and they give a unique photon, a different photon, which can be used as identity or the fingerprint of the element. Any doubt till this point? So electron can only transit if the energy is equal to difference. And that is also another reason why, like example, now sodium lamps are not common, but before, maybe you have seen this yellow orange street lights were used. Now it is replaced by mostly by LEDs, but before that it was used, the sodium street lamps were used. And before sodium, maybe you have seen, some of you maybe seen that mercury lamps were also there. So what is the reason when we are using a sodium lamp, it is giving an orange color? like it is the light which is coming out is orange in color. When we are using a mercury lamps are used, so it is in the high intensity, violet is there or indigo is there. So the reason is the same. The reason is because these atoms have different energy levels. So the energy level of the sodium, the gap between the energy level of sodium will be totally different from gap between the energy level of the mercury. And greater the gap, greater the difference, more energy is emitted out. So if we have a greater gap between the levels, energy, the photon energy will be much higher. And if photon energy is much higher, we have the formula E is equals to HF. The energy of the photon is, so it will give a higher frequency, and it will give an E is equals to Hc over lambda. It will give a shorter wavelength. So greater difference between the two shells, greater amount of energy release or higher frequency photon will be released or wave, and it will have a shorter wavelength. A wave which is associated with this photon will have a shorter wavelength. So if electron transit from second shell to first shell, or it transit from third shell to first shell, so because there's a greater difference, so this will give a high energy photon or high frequency photon or a shorter wavelength of a wave. Whereas when photon is emitted out due to the transition from first to the second shell, the energy of the photon release will be smaller, so frequency will be less, but the wavelength will be higher. The basically not frequency or wavelength of a photon, means the frequency and wavelength of a wave associated with this energy. So here high frequency, shorter wavelength. Here longer wavelength and smaller frequency. Is it clear, the concept of line spectra? Emission and absorption line spectra?